So in the screen, this is your project assignment or the group project. The group project is, as I mentioned, first class. It is writing an article. The article will be about some very new topic. Maybe you never heard about it in networking, because in your life as a network person, administrator, technician, engineer, whatever, you always have something new, and you really need to know how to describe to people this new technology. So this project is just an attempt to give you an idea of what you can face in this changing field, networking. Something completely new you need to investigate in a very short time. So just see what other people did. You don't have to make your own solution. I'm not expecting that. Usually these solutions would take maybe 4 master or PhD students to do it. For me, in 2 weeks, what I want you to do, see what other people are saying. What did they wrote? What kind of papers published in this topic? Write it and explain it later in a presentation. So 5 people maximum. In case you don't have a group, you can write in the WhatsApp group to make sure that you can get some people in your group, or you can join any group who's missing some members. Now, why you need 5 people, all of them to work efficiently? Because the work is a lot, okay? You see later, the requirement is to read a lot of papers. And if you want to do 1 or 2 people in the team to work, the rest of them, they just take free marks, that will not work for you. Make sure you distribute the job between all of you evenly, fairly, okay? And then let's see what you have to do. First task, of course, is to choose a topic. The topic is not something you choose by yourself. I will give you options. You have to choose from them. Next thing, you have phase 2 is to produce an article on the topic you choose. And last thing would be presentation. So now if you go to iTalim, this is iTalim. Okay, interesting. I forgot to upload the file. Just give me a second. It's there, but it's hidden, and the file is not the correct one. Just give me a second. Seems that there is an issue with iTalim as usual in the morning. And this is one of the things as network engineers we will deal with every time when there is a lot of network, a lot of load. If data root is not configured properly, directory doesn't exist. Okay. So iTalim suddenly decided to take a break. And in real life, they will contact you as a network administrator, come and help us. So now I don't know how to help. Just give me a second, sorry. Let's try maybe another browser. Okay, so simply iTalim is not working. Okay, interesting. iTalim is not working. So the project, maybe we can postpone this a little bit. I mean, postpone your access to the project, maybe a few minutes to start working. But I will explain it anyhow. So what you have to do first is to choose one topic. One topic for one group. You cannot have 2 groups writing the same topic. That's why you have to reserve or book the title you like. Okay. When you reserve that title, there is a link, supposedly in iTalim, for you to choose from number 1 to number 8. When you click on it, no other group can choose. So one member of each group should choose that the topic, the title you will write in. If two members choose two different topics, I would deduct marks because that would be unfair to other groups to choose two and then you say, oh, by mistake, someone else choose another topic. That's not acceptable. Okay, the topics we will be talking about. Sorry, just give me a second. Seems that some people have access. Okay. So the topic you have to write in, it could be, for example, block-based identity and access management. Here we are not talking about blockchain, sorry. We are not talking about blockchain. The main thing is how to do identity and access management using blockchain. So maybe in that introduction, you can mention a little bit something about blockchain, but it's not the main topic. If you write everything about blockchain, I will give you 0. That's not the topic. We are talking about identity and access management. Maybe you can talk about different methods, and then you mention blockchain methods, why it's good, why it's bad, what's the idea behind using blockchain. All this can be described in the article. Second one, AI-powered intrusion detection and prevention system. Now, this is a trend and all FYP students want to write on this topic. It's not easy, okay? If you choose this topic, it sounds interesting. It sounds like a future. It has a good future if you do this topic. It is, but for a very short time. After that, we have some issues with AI intrusion detection and prevention systems. So you don't have to do any model, anything about this. You just see how people are doing it, how other researchers are talking about these topics. And just for your information, last semester and the semester before, these kind of titles I put in the projects, many of the students will choose as FYP projects. It is doable. It's a good idea to do it. But of course, you have to discuss with your supervisor later to see if that's okay or not. Third topic is quantum networking. Quantum networking is what we will get after we get quantum computer. Everyone heard about quantum computer. It's like the next explosion in computer field. It will be super fast as they promised, although until now, the promises are not met yet, not even close. But we are waiting to see what will happen. But the problem with this one, when quantum computer will be there, what will happen to the network itself? So be careful if you want to write about this topic and any other topic. Read the title very clearly, very carefully. Quantum network, here we are talking about a computer sending data very fast. What will happen to the router? What will happen to the switch? What kind of cabling we can use? All these things we need to answer before we say that, yeah, quantum computer will be used. We have, in this network, we have challenges with the scalability, with the adaptability. We have a problem with security. We have too many problems. Some students, when they want to write about quantum, they will talk only about security perspective, which is a very serious problem. Okay. Now, let's say if China or USA got the quantum computer, suddenly all the password, all the security measures we have in all our systems, government, confidential data, everything will be open to them. That's the expectation. So every government now start thinking about what to do, how to save ourselves against this powerful computer, which we don't really know what is it, what is capability. So that's a very interesting topic now. However, whoever would do this one, the research, they don't have the real computer or network to talk about. They talk about theoretical aspects. They talk about mathematics. So interesting topic for those who like math, for example. Okay, next topic is multi-access edge computing and security. This one also a very interesting topic. It is related somehow to wireless sensor network, to sensors, IoT, and all these things. So if you have many sensors thrown in a jungle, for example, to collect data, the network connected to that one, we call it edge computing, okay? and it has specific characteristic compared to other computing networks. So now we want to see multi-access, and we want to see also the security of that multi-access edge computing. Again, the topics, all of them are new somehow. I want you to explore. I'm not expecting you to write a very perfect article at the end. It's just to explore what's going on there. Fifth topic is network sustainability and green networking. I think this sounds familiar somehow. But to write this one, you have a challenge to write something that will impress your lecturer and your friends to see that it's a serious topic. So you need to talk about it. What's network sustainability? What do we mean by green networking? Sixth is decentralized DNS and DDoS protection. Okay, so here we are not talking only about DNS. We are talking about DNS, by the way, they are servers, domain name servers. There are 17 or 18 of them all around the world, which make it super centralized technique. So now the idea, they are trying to find out how to do it decentralized, so we will not be affected by these specific devices falling down, and then there will be no internet at all. If we have decentralized DNS servers, DDoS attack will not be any problem anymore. So that's the topic, if you like to write about it. The next one is cyber physical system, security in networking. Focus about that. It's not only cyber physical system. It's not about security alone. I want you to focus in networking, how should we work on that? Meaning that don't write the topic in layer 6, 7 of the internet. I want to see what will happen at layer 3, maybe layer 4 and layer 2, these middle layers. So you need to talk about it. Next one is next generation firewalls. Also, this is very interesting, very, very interesting topic, next generation firewalls, because they deal with the networks security in different perspective. They have something called micro-segmentation. If you think about it, when you have a house, you have a gateway and you lock that gateway. But if you want to do micro-segmentation security, you will have different rooms inside the house. Each room will have a key and you lock that key. That's what we mean by network micro-segmentation in security. So next generation firewalls, it will not look at, okay, one firewall, we put it at the gateway, make sure that it protects everything. No, here we talk about we have to protect every single aspect, sometimes separately, by segmenting the network into different parts, and every part should have its own security measures. Very interesting topic also. So actually all of them are very interesting. But one thing, when you write it, the article, you write it for me, okay? But then when you want to present it, you will present it for your friend. So make sure you understand what you write. Write it in a language that's easy to understand for you, not for me, okay? I know the topics. I wrote already about, I have many articles about some of them. So the idea now, it's your turn. Write something you understand, and then you can present it, make it a clear idea. So if you write about next generation firewalls, I'm expecting you to explain it to everyone inside the class, and they will get the idea what is next generation firewall. Later, if they are interested, they can read your articles I'll provide it to you, or they can go and investigate more about this topic. Now, after you choose the topic, as we said, you have to have a group members. You decide one topic. Let me check if Italim is working or not yet. Is Italim? Because as usual, I always have too many windows opened. Okay, alhamdulillah, Italim is there. Let me check if the file is there or it's deleted. This is section 2. What happened to section 2? Section 1. Wow, I can access section 1, but section 2, no. What did you do? Okay, let's see what's happening with section 2. Okay, alhamdulillah, opened. So I should not blame you. Okay, if I got a project, just let me double check because I'm not sure if the file is uploaded or not. Here. And I'm not even sure where's the file, if the file here is the right one or not. So it's better if I upload it again. Yeah, clearly there's some problem here. Never mind, I can send it in WhatsApp group. Later I can upload it there. But before that, when you write, let me open all these things. Sure. Except for the article, I'll print it, send it to, nope, cannot. What's wrong with this one? Maybe I have to delete it. That will help. Okay, let me try to delete this one. Seems like serious technical issue. Okay, anyhow, let's go back to our, it will take a very long time to fix this thing. I don't know, station. So after you choose the topic, you go to iTalem. There is one link for you. Let's see if we can access at least that link. I'll show it in section 1. Okay, never mind. You can reserve the number 1 to 8. You're allowed to choose one of them. Okay, and after that, you start writing your article. The article should be IEEE template, 4 to 6 pages. What is IEEE template? Anyone of you heard about IEEE? Can you raise your hand if you have ever heard about what is IEEE? Okay, 1, 2, the rest are either sleeping or they didn't hear about it. Never mind. Simply IEEE is an organization. It was established long time ago, maybe 1950s, 60s, something like that. So they did it because when we start having computer electricity, all these things, by the way, previously computer was part of electrical engineering field. So the people find out that we need to have some kind of standards. If we don't have standards, you do your machine, I do my machine, then we cannot simply talk. My machine cannot read whatever data your machine produced. So they did this organization, do the standards. It's also a chance to get new ideas. So they start making conferences. IEEE conferences are very famous. In IIUM and KICD, we will have one next month, inshallah, IEEE conference. It is a recognized one and a recognized conferences. And also what will happen in these conferences, everyone will write their paper in the same template, which means that if you open any IEEE paper from any conference made by IEEE, you will find that all of them are having exactly the same, they look the same font size. Just, is it open? Okay, let me show it to you. Where is that? IEEE, it's not opening. Okay, this is how the template for IEEE looks like. Any conference you see, only this part will be changed. Okay, this one depends on the name of the conference, but the rest of them, the font size, it will be the same for the title. This is how we write our names. The name will be here, and then we have the department, country, all these things. Later, we will have the email address, author 1, author 2, and so on. If you need less number of authors, you have 4, you can delete 2 of them. If you have 5, you can delete 1. And then we rearrange. For example, if you have 5, you can remove this part. Sometimes it's a little bit hectic because what you have to do, let me just show you. You look here, it is 4 columns. This part of the paper is 4 columns. If you want to make it 3 columns, you can from layout, and then you can change to 3 columns. In that case, you can see it would change. If you want to make it 2 columns, okay, also you can do. So the idea also from this project is to let you get used to these templates, because in FYP project, you will write your progress report using IEEE template. So it's a good training opportunity. After that, you have the abstract. Usually the abstract, we write it at the end. After you finish everything, you summarize everything in an abstract. Now you have the keywords also. The right way to write the keywords are words related to the topic. You need them if you want to search about the topic, but the words are not mentioned in the title. For edge computing, for example, you don't say here edge computing. You will find other terms which can be useful if I'm searching for that topic. So yes, I just need to see the chatting box in case any of you want to have any question, you can ask at any time. Let's continue. Okay, so this is the title, the introduction, the heading. This one is just a direction. You have to delete it. Then you see the font size is 10 for all IEEE templates. The font size are 10 times New Roman. So when I say 4 to 6 pages, I should see the 2 column. It should not be 1 column. 1 column, I'll deduct maybe 10% of your mark. Okay. IEEE, you have to follow IEEE. Now for the font size, you cannot change it. It should be exactly the same. You can see here how to write the font size for the subtitle. Right here, sometimes we have subsections inside the subtitles. But all these things you can follow in order to get at the end, every IEEE paper will look the same. 2 columns, same font size. It will be easier. We don't have someone having a lot of colors, having different way of organizing the papers, because these people, technical people, they care about the content much more than how it looks like. One thing also worth talking about, it is the table. The title should be above the table, but if you have a figure, the title of that figure should be below. And inside the text, you should mention the table 1 is talking about this. Figure 1 is representing or showing this and that. If you don't do that, that's also a mistake. Another thing, the citation, because you cannot simply write your own thing at this stage. You read from different references, and then you put it here. So if you want to say Mr. X said something, you say it, but you don't write Mr. X. You just write between square brackets. You write, for example, 1, 2, 3, 4, 7, up to 7. Mr. This one, reference number 7, said this. If I'm interested as a reader in whatever mentioned before this, I will go to the reference list, check 7, I'll see who did it, what is the title, all the information if I want to read more. So you start this one, of course, first one should be 1, 2, 3, 4. It's not alphabetically ordered. It depends on when it appeared inside the text. So that's in general. I will leave it to you to explore a little bit about this one, about how to write article with IEEE template. Now, if I go back to our project, I know I'm taking time here. Okay, let's see. Okay, should be 4 to 6 pages using IEEE format. From that title we decided in, and the article should include the following. First of all, as I said, you will explore what other researchers did. So I want you to have one table at least that's comparing between different approaches, different techniques, different methods, different research, okay, different papers. What did they do? What's different between them? I want you to compare them. Okay, otherwise, you just copy, paste. That's not helpful. I want you to understand the differences between them. Another thing, you should have figures and diagrams. In networking, we cannot see internet. We cannot see the internet. If I explain to you from now until next year, the internet without having figures to imagine what's happening, it's impossible for you to understand. So if I go now to ResearchGate, let's go to ResearchGate. ResearchGate is one of the good websites you can go to find papers, references for your topic. So now in ResearchGate, every author can put their papers, of course, if they don't have the copyright issues. You can upload your papers and people can start downloading the paper, citing your work and so on. If I want now to write something about intrusion detection and prevention system using AI, one of the titles, right? If I click on that, I will get too many papers. Let's see how many of them. 6,700 pages. Okay, each of them I think 10. Okay, now some of them you don't have the paper itself. Some of them you will have the paper. So let's see this one: integration of AI machine learning intrusion detection and prevention system. I'm telling you, every paper will have some pictures. If it has no pictures, that's not a good paper. Should have table. No picture. Where's the picture? There's no picture here. This paper is not good. To have a good, because we cannot imagine what they are talking about. Let's say this one, smart intrusion detection using IoT, industrial. You can see how many pictures they have in here in this article. This is one picture, two picture. Now when I read about IDS in Internet of Things network. So when I see it now, I can imagine where exactly the attack will happen, what it will attack, and what will be affected. Next one, also explaining the AI CNN. This is the AI algorithm. Then it will show you this algorithm, the AI model or algorithm, where exactly we will put it inside the model. All these things are just imagination, but it will help us to implement and understand what's happening. That's why every paper, good paper about networking should have figures and diagrams. Not random figures and diagrams, but things are related, figures related to the topic to make it easier to understand. Now, the bad news, I don't want to see less than 20 references. You are 5 in the group. If each of you read 4 papers, at the end, it will be easy. Okay, 12 of these 20 references should be conference and journal papers. I don't want to see Wikipedia. Wikipedia is not reliable and trusted source of research papers or research topics. It's okay to have some websites. That's acceptable here, but in real life, when we go to conferences, they don't accept websites. Should be conferences or journals. Why? Because before you publish in a journal or conference, there are some other people, experts, who will read your paper and approve or disapprove. But the website, you can write anything. Correct or not correct, doesn't matter, right? No one would check after you. And I want to see the paper with 5 sections at least. Don't use AI. ChatGPT is so stupid in research. It's not useful at all. You may see some AI tools that claiming they are useful for research, but they are not really, because AI cannot generate idea. AI just paraphrase the ideas already existing and keep repeating and repeating. There are AI detection tools. I will use them. I don't want to see 100% of the paper generated by AI. It's okay to have some of it generated by AI, but not all. Use your own sentence and make sure that you don't copy and paste without changing anything. That's not allowed. After you do that, you do the presentation, inshallah, and the group presentation will be during the class. You will not present to me, you present to your friends. So make sure everything is clear. Even when I listen to you, I will listen to you as a person hearing about the topic for the first time. If you can make me understand it, you'll get good mark. If you make me get confused or not interested in the topic, low mark. Okay, any questions? We took a long time already in here. Do you have any questions? Yes? No? Sleeping already? Okay, raise your hand if you are still awake. Let's do this one again. If you are still awake, raise your hand. Wow, only 3. Okay, 12. That's good. Okay, so 12 are awake, 13, the rest of you, that will be around 16 of you sleeping. Sorry for that, for make you sleeping. Okay, just let me check for the last time. This is section 2. Let me check if I can change the file for the project, because the file here is outdated. The dates, I think, are not the correct ones. Okay, alhamdulillah. So now I can put the correct one, which is this one. Okay. Now, if I go back to the project, let me show you how to choose. The template is here, IEEE template. If you click on the choice, you will see here that you have different choices, 8 choices. One of you, of the group members, should choose which topic you want from 1 to 8. Okay. When you choose it, it will show it's full. You cannot, the other groups cannot choose the same one. So that's the choice. After that, you have to submit the project article. But before the project article, I want to see a file, small file, on before Monday, which means Sunday before midnight. Not a file, just put the title you choose and the group member's name, because I don't want anyone to be left out without a member until the last moment. So make sure you submit it on time. On Sunday, everyone should have a group by that time. Later, you write in the article, you submit it here, and the presentation later should be here. And just not to confuse you, I will hide project 2. Project 2 will come after you finish project 1. Okay, so now you have an idea about that. Let's go and continue what we were doing last time in Net Academy. We were revising computer networking course. In the computer networking course, we studied a few things there, which are related to our topics here. I will focus only on that thing. Now you have access to the course material. You have the PowerPoint in Italian. You can access here, Introduction to Networking, and see the activities, see the packet tracer, everything is there. So since you have access, you need to revise anything, you can come here. We finished module 1, 2 can skip, 3, 4, 5 numbering system. I assume everyone knows how to do a numbering system. Data link layer done. Now we are at Ethernet switching. Ethernet switching, this is a topic which is so related to this course. You really need to understand how the switch is working, because most of what we will be doing in VLANs, what we will be doing in security chapter related to this topic. Ethernet at the end, if you check section 7, module 7 and module 6, somehow they are the same. Module 6 talking about data link protocols in general. Module 7 taking a specific data link protocol, which is called Ethernet, and start talking about it. Now, Ethernet has few jobs to do. We have something called Ethernet encapsulation. Now, Ethernet protocol or technology in general is dealing with different kind of bandwidths. All of them are wired LAN. Okay, wireless LAN, different protocol, will not be the same. Fiber optic, different protocol. So this one is working data link layer, Ethernet data link layer, and physical layer. Physical layer means that the wire should be Ethernet wire in order for Ethernet data link layer protocol to work. You cannot put the wire as fiber optic and then use Ethernet. That will not work. Now it's dealing with different bandwidths. We have 10 megabit per second. We have 100 megabit per second. This is the blue one, if I'm not mistaken. We have 10 megabit per second, or called 10 gigabit per second, and so on. But the one we use usually is this one and this one. This is 3 actually. Okay, this is the range of bandwidth is we are using. What's the meaning of bandwidth? Simply how much data the link can handle per second. So for example, this one can send 100 megabit every second. Mega, how many zeros in the mega? Can you put in the chat box or tell me in the microphone? How many bits? How many zeros, sorry, in the mega? Yes, 6 zeros, okay? So if we have 100 megabit per second, we are talking about 8 zeros, 1 and 8 zeros. Okay, so this is in general the bandwidth we are using, and as I mentioned, should be layer 2 and 1 involved. So layer 1 is the cable we connect or the wireless adapter we switch on. Bluetooth also could be there in layer 1. Since we activate that one, in the adapter I showed last time in the control panel, you have different adapters. The protocol will start working. The driver, you study operating system, you know what's the driver. The hardware driver, it is the piece of code that will translate or convert the signal you get from that hardware to something understood by the computer or the operating system. So this is the job of the data link. Now, if we look at the sub-layers of data link, I think I mentioned it last time. It's data link because it's dealing with the hardware and the software, the real world, the physical, and the logical one. It needs to be divided into two parts. One part, we call it media access control. This sub-layer will deal with the physical layer and make sure the physical layer can transfer the digits, can correct if there's any error, if there's any issue, it will deal with it. Then it will send the data to the sub LLC, link logical control. Okay, it means now from the hardware, the signal you get at LLC, it will be understood by the upper layer. Here we have one standard for IEEE. You remember the IEEE template I talked about? It's the organization called I forgot the name, International Electrical and Electronic Engineering Organization. The National Electrical and Engineering and Electronic Engineering. Internet communication are from beginning belong to electrical field. So these people, they have different standards. One of them is called 802.2. This 802.2 will understand is the standard that simply take anything from here, translate it to something understood by the network layer. Okay, we don't have to worry a lot about it. The encoding will be done here. We don't have to really worry about it. That will be the operating system people, electrical engineer people, computer engineering. So we are safe. But we need to know this one. And you can see Ethernet is one of them. It has 802.3. This is dealing with Ethernet. 802.11 dealing with wireless LAN. 802.15 dealing with wireless personal area network, and so on. Fiber optic will have different name, and so on. Now, for MAC sublayer, simply it is the one giving us the, it's forming the frame. You remember the frame? We talked about the frame previously. So frame is the name of data unit at data link layer. I drew it before, we said it's data, then it became segment after we divided it in layer 4. When it got to the network layer, it will be called packet. When it got to layer 2, it will be called as Ethernet frame. Now this one, if you remember, we called the frame because some information, this is the data, you can see the data here. There's some information added at the beginning before the data and some information added after the data. So that's why we call it a frame. These headers and trailers are framing the data. Now, what are the information we get? We have some 8 bytes. These 8 bytes is just a stream of 1 and zeros to make sure to prepare the link to receive the frame. We don't worry about that. Then we have MAC address for the destination, source MAC address, length of the data will be inside. Also, we have to know. Type, it will mean that from the upper layer, layer 3, what did we get, IPv4 or IPv6? Here it will be stated. Then we have the data, and then we have the frame checksum. I think I talked about the frame checksum last class, but it will be always useful to repeat it again. Okay. Frame checksum, simply after you send the data, you will send a stream of 4 bytes. You see, let's check that one. It is 4 bytes. 4 bytes are frame checksum. 4 bytes mean how many bits? Can you tell me in the chat box? If you have 4 bytes, how many bits are these? Exactly, 32 bits, because every byte is 8 bits. I don't know what's happening with every website I open it today. This is also slow. Okay. Now, what will be inside these 4 bytes? According to IEEE standard, there'll be some agreement between all devices. If you want to send data, after you send it, you have to send a stream of ones and zeros. They will agree upon how many ones and how many zeros, but there will be 32 bits. So let's say there will be 1, 2, 3, 4, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0, 0, 0, 0. If I'm not mistaken, that's, okay, 8, 16, that's 32. These 1 and 0 will be sent just to check, is everything okay with the data we sent, or there's something wrong happening? So if something happened on the way and some noise, some outside interference with our data, change this 0 into 1. And then later, something happened, maybe here, this one became, or this one became 0. Now, the sender sent 111,000, 111,000, as it's supposed to be. However, on the way, something changed. The receiver received the message, read the data already. Then the receiver get, okay, 4 ones, that's okay. Then 10, 100. It's not supposed to be like that. It's supposed to be 000. Something happened with this bit. So this bit having an issue. It's not a correct one. Something changed on the way. Now it will check again. 111,000,1, and then it will come here. Oh, 3 ones instead of 4. So definitely, this one was changed also. Now, if we look again at the data, where's the data? Directly before these checksum bits. It means if this one is changed, there's a big chance the data changed also. We cannot accept that. We cannot accept a single bit of the data to be changed. I show it in the enterprise network. Sorry if you attend both classes, but some of the things I have to repeat. So I will take one of these pictures. Let's say this one. Copy it because I don't want to lose that picture. In here, I will open it with Notepad. And we saw last class that we can open it, but the data will not be something as a human being we can read. That's why we say presentation layer is very important, because presenting the data in a way we can see. So let's say this is something we cannot read. Let's change one single, before I change, let's do this one. I open the picture. It's opening a very nice picture, flower. Maybe you don't like it, but I like this flower. Okay, anyhow, now Notepad, and I will change one single, let's say take one thing, this 2, I'll make it 1. Save it. And let's open the picture again. What we will see, it will tell you that the file is corrupted. The entire image is corrupted just because one bit is changed. Same thing if you have a text, one bit change, You cannot read it anymore. So that's the idea why we should not tolerate any single bit of the data to be changed. And that's why what we have the frame checksum to check, is everything okay? If something changed here, there's a big possibility the data itself was changed. So if that's happened, I have to send to the sender, to the source, say that something happened on the way, send me the frame again. I cannot accept it. This checking of errors will happen at layer 2, and it happen a lot, okay? After you do that, when you send the message to layer 3 or to layer 1, now we know that everything is fine. There's no errors on the way. Maybe some other errors will happen, but on the way, there's no bits missing. Now for the data itself, we can have 46 bytes of data inside this frame. With the header, it will be 64 as a minimum. Maximum is 1,518 bytes. We cannot get less. If you get 32 bytes, something wrong happened. On the way, your package was broken. So you will order it again, right? Same thing, if you get it very huge, it means something was added. And some of the attacks will use this one to attack the network. If we meet in the class one day, I can allow you to attack my device using a giant frame. You can attack my computer until it will collapse. If we are in the class, physical class, same place, not now. So yeah, now let's see if I open Wireshark. I think some of you know Wireshark. Can you raise your hand if you have ever used Wireshark in the class? Raise your hand if you used it, not only heard about it. Okay. 12, 13, let's say half or less than half know it. Never mind, we don't use it a lot. Usually security people, you will use it a lot, I believe. So now if I open the Wireshark, look at it, you see those adapters we saw last time already here. You have the Ethernet, VPN, VirtualBox, local area, VMware, everything. You see the active one are 2. This one not supposed to be active. Look back, it's fine, that one. Okay, Wi-Fi is what I'm connected to right now. That's why it is active, having some signal. If we switch on it, you will see that we have a lot of messages going on. Now I will stop capturing these messages. These messages, by the way, not necessary to be from my computer, could be any computer. This one, 10.111.33.222, this is my computer. This is the source. Because I'm talking, it's sending the message to this IP address. This IP address most probably is the IP address used by the cloud of MS Team for my voice to be sent to you. UDP, it's the protocol used in level 4 to send voice, okay? Not text, but voice. We don't care about level 4 now, but what we care about is layer 2 information. You see here, Ethernet version 2 is here. And if you expand it, you will see the source and the destination MAC address. Source and destination MAC address are here. And you see the type. You remember we said the type of data will be also one field saying, is it IPv4 or IPv6 data? If you check the frame size is 1,226. I go back to my website. Let's see if it's inside the range of acceptable frame size. You see, it is in between this range, so it should be okay. If it's larger, could be an attack or could be a problem. If it's smaller, also could be an attack or could be just some errors happening on the way. So it would detect. There are a lot of information here, frame number, there are frame length, frame capture length, and too many other things. For those who study security, some of these fields are very, very useful to detect attacks or to do attacks. Okay, so interesting things can happen here. Interesting information also can happen here. For me to get the arrival time, this one, I can play with this time. and send a fake message with a slightly different time, and then the other side will believe that it is a real message. Anyhow, the idea of the Wireshark is simply if we capture the data, all of them, the size will not exceed the limit we have here, between 64 bytes until 1518 bytes. Now, Ethernet frame fields, okay, we can skip that one. Check your understanding. This one very useful for you to do it by yourself. I like to, even, especially when we start the real topics, I like to bring the MCQ for finals from this question. Check your understanding, telling you a hint, okay? But there are a lot, you have to study it, you have to understand it. Now, if we go to MAC address, you remember last time we said MAC address would be hexadecimal, 48 bits, and it will be used in layer 2. What will happen with the source and MAC address? Let's see this video. If I switch, if a computer, host 1, want to send information to host 3, okay, it will send a message. Usually what will happen, it will go to the switch. When it will arrive the switch, okay, this is first the message itself. You have the destination address and the source address. But if the switch is not aware where is the destination, what it will do, it will send this message to everyone. So you see, it will reach the switch and then everyone will get a copy of that switch. Sorry, of that message. Now, host 2 or computer 2 will see that one, say, this is not addressed to me. I'm not the one having that address. This destination address is not mine. So simply I will ignore it. Computer 4 will say, okay, this is not mine. I will ignore it. Computer 3 will say, oh, this is mine. I need to reply. Now, this is the problem is it doesn't make sense. Simply every message you want to send to a specific device, you send it to everyone else. Because for computer 2 and 4 to say that this is not our message, they need to take it, put it at the RAM, then send it to the CPU, CPU process it, CPU send a message saying this is not my message, and then ignore it, give a decision, right? So it doesn't make sense that all the things sent here from anyone go to everyone, because it will affect the CPU and the resources of all the devices in the network. Just to give you an idea, if we have this case that every message we sent inside IIUM, everyone else will get it, but we want to target only one destination. So IIUM having thousands and thousands of devices. If everyone send a message every second, it means that your computer will receive maybe 1 million messages per second. And it should process them and say, oh, this is not mine, this is not mine. This is millions of them will be not yours. Only one will be maybe sent to you. That doesn't make sense. Your computer battery will be affected, your CPU will be affected, the RAM will be affected, your computer will be very slow all the time. So this cannot be done. That's why having a MAC address will help us to know exactly to whom we want to send the message. We have different approaches. One of them, we call it unicast MAC address. Unicast simply means that you know your target, your destination. This computer one want to send a message to the server, and the computer knows what is the MAC address of the server, what is the IP address of the server. How do the computer get it? It is easy. For the IP address, just for example, if I go to command prompt, type ping IIUM or Google. Let's see the Google server. Where is it? Where's Google? It's here. Is it inside IIUM? No, IIUM IP address is 10 dot something. Now, where is this IP address? Let's check. This is something interesting we can do. We can search for something called IP location. I don't want to put it here. Just a second. IP location. You will see many websites called IP location. Okay. I click on it, anyone. The first one I think is good. Internet is very slow. Okay. Put the IP location we just get. Here it is Google server, right? Remember when I write google.com, I get this IP address. So now I want to see where's the server for Google. IP lookup, give it time. Then let's see, still processing. Sorry, too many and advertisements everywhere. Okay, this information you see here, these are my current information. I'm from International Islamic University of Malaysia. That's why I live here. But I want to see the IP address of Google. So this is the IP address. Let's see where is the server. The server is, you can see the ISP is Google LLC. The country I'm connected to when I try to connect to Google, it is India. Can you try to do the same in your computer? Wherever you are from, can you try to go to command prompt, ping google.com, take the IP address you get, this one, and open this website, iplocation.net, put the IP address on the top here, and tell me, is it the same country or different country? Me, I'm connected to India. Let's see if you will be connected to India or different country. Okay, you can do it fast. Okay, go to command prompt, just type in the search CMD. You will get the command prompt. You'll get this black screen. Type ping google.com. When you do that, between brackets, the first line, you will get IP address, this one. Copy it. After you copy it, you can go to this website to make it shorter for you. I'll put it in the WhatsApp group. Where is WhatsApp group for you? Okay, here. I'll put it here just to make it faster for you. Instead, you go and search here and there. And tell me, after you paste the location in here, sorry, the location, you put it here, the IP address you got, put it here, then enter, you will get some information. Is it similar to my information or different? Okay, we got someone in Singapore. Anyone else? Anyone else get the country different or similar? Can you write in chat box? And the interesting thing about this specific website, if you go to map, it will give you exactly where is it in India. It's not just the country. So you can see the server of Google I'm connected to is here. See, we got many different answers. Someone is connected to Australia, someone Japan, India, and so on. Why do you think we have different? We're connected to the same website. Why do you think we are getting different IP addresses in different countries? How can you explain that? Anyone want to try? Okay, so let me say it, because this is the idea of the cloud. When we use cloud computing, Google is using cloud, we know that. It means that you have many thousands or even millions of devices. Can you Google it just now? Or ask ChatGPT how many server Google is using? And give me the number in the chat box. How many servers are used by Google? Are you getting thousands? 10,000 or more? Anyone? The number of servers used by Google. No answers? What's happening? 3 million. Okay, 3 million. 3 million servers. So these servers, all of them are in different countries. Some of them in Singapore, some of them Australia, Japan, India. Okay, when we try to ping Google, it can send us to different server. However, because we are using a cloud simply is just like the cloud we see in the sky. It's just like something we don't know exactly what is it. Okay, we don't know where we are connected to. We will see one website, that's the interface, but the real server we are talking to is different. That's simply what is the cloud. A cloud of servers. The user will not know exactly to whom it will connect. Okay, estimated. Okay, someone saying it's 900,000. That's also possible. I heard about 4 million also. At the end, any of them, any number of them, it's a huge number. And to manage all of them, that's managing cloud is not easy. Cloud infrastructure, this is a topic we will have very soon, inshallah, and for the next batch, they will study it. Cloud infrastructure management is not a simple thing to do. It is not about you use it only, upload a file to Google Drive, to OneDrive or Google Drive and so on. This is a user, but if from engineering and administration point of view, very complicated. Okay, so that's simply what is the cloud, just give you an idea about it. Now, if we want to check, we got already the IP address of the server, but just by writing down, what is that? The URL. Now, for the MAC address, can be given to us by the ARP, Address Resolution Protocol. It can help us to get the MAC address. Every computer have a MAC address. Every server, every switch, every interface of the switch will have different MAC address. Now, when you get this information, what will happen for unicast? You have all the information. You want to send the message. The switch would take it, know exactly to which device it was sent. However, sometimes you have cases that you don't know the MAC address, or you intentionally want to send to everyone. You want to broadcast the message. You want everyone to know that you are sending a message. An example of that, if you are entering IIUM campus, your computer will send a broadcast message everywhere asking, how can I connect to the internet? And then they will reply to you. You look at the network lists you have in your phone. You'll get few networks, IIUM staff. What are the networks? We will see if I check here. See, these are the networks. How did I get the network? Simply my computer sent to everyone saying that, hello, I'm new here. Can I connect to any network? So intentionally, you try to send to everyone. If you want to do that, what you do, source MAC address will be your MAC address. Source IP address will be also your IP address, but the destination, you will put all one. FFFFFF, okay? That to say that I want everyone to receive my message. Now for the IP address, destination IP address, also you will use the broadcast IP address of your network. Now, let me just double check that one. If I type on ipconfig, maybe I'll get the ipconfig broadcast is there. Nope. ipconfig, just a second. Sometimes they put it, ipconfig all. Maybe I'll get the broadcast message for some of them. So then broadcast IP address. No, it's not there. I think that would be the next start. Next start. Oh, not even this one. Okay, never mind. So we can check that one later. Anyhow, broadcast message, we'll talk about the broadcast address later, IP address. But for the MAC address, it will be FFF. What will happen? You try to use it. The computer will send to the switch. Switch look at it. It's a broadcast message sent to everyone. Next step, Now, a multicast. We have sometimes some technologies like STP, LDDP. We will study them in this course. For enterprise network, we have the OSPF. The routers want to talk, only the routers. Or STP switches only want to talk to themselves. They want to send to everyone, every switch in the network. Not everyone, sorry. They want all the switches only to receive that message. So in that case, multicast will be a good choice, meaning that one to a group, one computer sent to a group of specific computers. The rest, if they get it, they will just ignore. But in multicast, actually, we don't want even to send it to the others. So that's the idea. Now let's go to MAC address table. I think I'm a little bit late here. MAC address table, if I want to draw it, okay, let's not to draw it. I would take it from the computer. For the computer, for the switch, this is switch. If the switch want to understand where to send the message, what it would do, let's take this one. I don't want to draw, I want to save time. This is a switch. We just turn it on. The RAM is completely empty. There's no information related to anything inside this switch. And we want simply this switch to be able to connect different devices. Okay. So there is what we call ARP, address resolution protocol. This address resolution protocol helps us to fill this table, MAC address table, with an information. Every port we have here, the port is the plug-in place in your switch. Every port will have a number. We want to know that port connected to which MAC address, to which computer having which MAC address. How that will happen? So let's say now PCA want to send to PC C or D. PCA want to send a message to PCD. We have two options. Either PCA want to send PCD and we have the MAC address, or we don't have the MAC address, but we have the IP address. So when PCA send the message, we have information should be there. What are the information? We know from previously, we will have destination, MAC address will be there. We have the source, MAC address will be there. We have the IP address, destination, IP, and we have the source IP. Okay, this information, we will have it in every frame we send. Now, if we want to see here, destination MAC address, if we want to send from PCA, what will be to PCD? What will be the destination MAC address? Can you write in the chat box? Destination MAC address here, 0D, right? 0D is the destination MAC address, 000D, but I don't want to write the 00s at the beginning, it's long. Next, source MAC address will be 0A, because computer A wants to send a message. And then you have the IPs. Currently, we don't have to worry about IPs. This message we want to send, it will go up from here, go to the switch. Now the switch will receive it. Look at the MAC address table that the database is having. There's nothing, it's empty. So what it would do, two things. First of all, it would take the information we just received. We know that from port 1, we received a message from a computer with a MAC address 0A. So let's record this information because it will be useful in the future. I put port 1 is connected to 0A. Later, next, what I have to do as a switch, again, we have to think like a switches. As a switch, I don't know where is the destination. 0D, I don't have it here, not in the table. So what to do? Since I don't know where is it, I will send to everyone connected to my to my ports. The switch was sent to everyone. Send a copy of the message to everyone. Now, computer B will look at the IP address, say, no, this is not mine. I have nothing to do with this message. Ignore. Computer C also say ignore. Computer D will say, oh, it's my message. Now let me reply. So it will make a new message. What will be inside that new message? Also, it will have the destination MAC address. Can you tell me what will be the destination MAC address? And what will be the source? Write it in the chat box. What is the destination? What is the source? Computer D want to send to computer A, want to reply to the message. Destination will be 0A, and the source will be 0D. And of course, they will use the IPs. IPs, we'll talk about it next class. Now, this computer here, sorry, okay. This computer here will reply. D will send here a message. What will the switch do? Okay, I got a message from port 4. I just got something from there. And it happened that that port is having connection or connected to computer with this information. Check the table. Do we have this information here? No, it's not there. So it's a good idea to add this information for future. At least we'll have, I will know that port 4 is connected to which device. So here I will have port 4. Who is connected to port 4 is 0D. This information will be there. Now, I want to send the message. It's not enough to fill the table. Can I forward the message? Do I know where to take it? Which exit it should use? What do you think? Can the switch knows to where we send this reply? Yes. How it will know? It will check. The destination is 0A. Do I have 0A here? Yes, it is here. So since it's here, I know it is in port 1. No need to bother the other computers. Just take it directly to port 1. Okay. Now let's say that B want to send a message to, okay, PCB. Want to send a message. Sorry, I know that time is out. I'll take 1 minute only. Want to send to PCC. However, we don't know what is the IP address. I don't know, sorry, what is the MAC address? I don't know what's the MAC address. PCB want to send to PCC, but I don't know, PCB doesn't know what is the IP address. So what will be the destination in this case? If you don't have the destination MAC address, what you have to put? You put F, everything F, okay? F. And the source will be PCB, 0B. Now the switch, oh, and of course you have the IPs as well, should be there. You cannot send anything without the IP. Now, what will happen? Let's take another color. The message will come from PCB. Let's delete also these things because now it's get confusing a little bit, okay? Now, the message will leave PCB, go to the switch. Switch, look at the table. Do I have any information about port B? Oh, sorry, port 2, the second port. I have no information here. This is a new information that the MAC address is there. So the MAC address table will key in this information. Port 2 is connected to a device with the MAC address 0B. Now look at the destination. What will happen after we look at the destination? FF. Oh, this person wants to send a message and doesn't know where is the destination. So simply now everyone else except the source will get a copy. FF means everyone should get the copy. Okay. When they get copy, now computer C, this one, we check the IP address, know that, oh, I'm the one it want to talk to. So only computer C will reply. Also, this information is not here. Who's connected to port 3? This information is not there. 3 connected to 0C. And where is 0B? We know directly from this entry that 0B is there. We just send the message to that entrance. Hopefully it's clear. We have to stop here. Sorry for taking 4 more minutes. Inshallah, next class, if this one is not clear, we can repeat it, inshallah. And we start with the submitting. I don't know how long we need to take because I found out some of you didn't use the devices. How many of you used the console cable before this? Can you raise your hand if you use the console? You know what is the console cable and you used it before. Can you raise your hand? Console. Okay. So 4, and the rest either sleeping or they didn't use it. Which means that we need maybe to spend some time in Cisco Lab, but it will not be next class. Next class will be online as well. Inshallah, we were promised that Cisco Lab will have aircon by this Friday, which is tomorrow. But of course, we have to wait and see when they try to switch it on, it will work or not. If it's not working, it will not be a good idea to be there. Okay, so I will let you know. Next class will be online, inshallah, but after that, we will discuss when to use the lab, inshallah. So that's all for today. Thank you very much. Don't forget that attendance, don't forget the project. Book your project fast before the title you like is already taken by someone else. Because I think if I check now, I will find that some of the titles already gone, maybe. Let me check that one. Okay, and if you have any question, you can ask. I'll stay 1 more minute after you leave. And of course, in the WhatsApp group, you can ask anything at any time. Inshallah, I'll answer you. If you forget the attendance for the previous classes, just let me know in the WhatsApp group. Don't send to me. If you send private message, I will forget it later. But in the group, it will never go. I will check it when I get free, inshallah. Thank you very much. And assalamu alaikum wa rahmatullahi wa barakatuh.
Walaikum assalam wa rahmatullah.
Thank you, madam.
Thank you, madam.
I cannot use the chat box. Maybe I'm not inside the Teams.
Okay, brother. If you want to be inside the team, I will give you the code. In WhatsApp group, you have to use the code in order to join. So let me see where is the code. The code is this one. Okay. So I'll put it again in WhatsApp group. Use that code to join the team, and then you can use the chat box, inshallah. Okay.
All right. Thank you, madam.
Okay. You're welcome. Okay. Anything else? Nothing? Thank you very much. See you, inshallah, next class. Assalamu alaikum wa rahmatullahi wa barakatuh.
Thank you, madam.